Hello everyone, today we will do last part of the lesson classification of element from class 10. Okay, so student, in previous video we complete this periodic trends in the, we have started periodic trends in the model periodic table, and we did two properties like valency and atomic size. So today we will do last property, which is metallic non-metallic character. So how this periodic trend will observe in metallic and non-metallic character across the period and down the group. All right, so let's start. Okay, so student, this is a periodic table. All right, so look at the elements of the third period. Where is the third period? This, the third period starts from sodium and it ends with an argon. So observe the third period and classify them into metals and non-metals. So we will observe that metallic elements. Okay, so towards the left side, the metallic element like sodium and magnesium are towards the left side, and the non-metallic elements such as a non-metallic element towards the right side, like this side. Okay, so sulfur, chlorine are towards the right side, and this is a zero group element, which is argon. Okay, and the metalloid element, so these are the metallic element, these are non-metallic element, and we have metalloid also. So where is the metalloid? This is a zigzag line. Okay, I have told you the elements which lie along the zigzag line are the metalloids. Okay, so here silicon is a metalloid because it lies along the zigzag line. Okay, so this is for period 3, but a similar pattern is all observed in the other periods also, like second, fourth, fifth. So in each and every group the similar pattern is observed, like metal towards the left side, non-metals towards the right side, and metalloids are present along the zigzag line. Okay, so silicon zigzag line, this present along a zigzag line, which is a metalloid. All right, so cations form from a metal. Okay, so metal will form a cations and anions form by a non-metal. Okay, so what are these? Metal atoms have a tendency to form a cation. Metal atom has a tendency to form a cation by losing electron. Okay, by losing its valence electron. Valence electron are the electron which are present in the last shell or the valence shell. Okay, and this property of a metal to form a cation by losing valence electron, it is known as a electropositivity. This property is electropositivity. Okay, electropositivity. Okay, so metals are the electropositive elements. Okay, and on the other hand we have non-metals. Okay, so non-metal has a tendency to form a anions. Anions means negatively charged ion, and cations means positively charged ion. Okay, and non-metal has a tendency to form anion by accepting or gaining electron, by accepting or gain of electron from the other element. Okay, and this property of element of non-metal, which to form an anion by accepting of electron, this is called as a electronegativity. Electronegativity. Okay, so non-metals are electronegative element and metals are electropositive elements. And ions have a stable electronic configuration of a noble gas. Alright, so ions have a stable electronic configuration of a noble gas. Noble gas which is present at the last group. Okay, which is present at the end group of each and every period. Okay, now here we have one question, that how is the ability to lose or accept electron in the valence shell determined? Okay, and all the electrons in an, okay, so this is the structure of an atom. This is a nucleus and these are the shells around the nucleus. In each shell there are particular electrons are there. Okay, so the last shell is called as a valence shell, and electron present in the valence shell are the valence electron. Okay, now all the electron, now answer this, let's answer this question. All the electrons in any atom are held by the attractive force exerted on them by a positively charged nucleus. That means this nucleus experience a positively charged this nucleus experience a force of attractive force between the electrons which are present in particular shells, and electrons in the inner shell lie in between the valence shell and the valence shell and the nucleus. Okay, so these are the electron in the inner shell. Okay, electron in the inner shell, these are lie between the valence shell and a positively charged nucleus, and because of their presence the effective nuclear charge exerting an attractive force on the valence electron is somewhat less than the actual nuclear charge. Okay, so this is somewhat less than the actual nuclear charge, and thus the number of valence electron in metal is small. The number of valence electron in metals is small, that is up to 1 to 3. Okay, that means in valence shell of an electron only one in metals. Okay, in metals the valence electron are less, very small, which is 1 up to 3. Large shell only 1 to 3 electron will be present in metal. And also the effective nuclear charge exerting attractive force on the valence electron is very small, and as a combined effect of these two, okay, as a combined effect of these two, what effects the as a combined effect of the two factors, that is attractive nuclear force and these two factors, like metals have a tendency to lose a valence electron to form cations having a stable noble gas configuration, and this tendency of an element is called as a electropositivity, and the electropositivity is a metallic character of that element. So this is a metallic character of that particular elements. Okay, now let's see the periodic trends in a metallic character in each element. Okay, now student, while going down a group, okay, down a group like this one, while going down a group, metallic character of an element increases. Okay, this is increases. Okay, so while going down a group, metallic character of element increases. Why? Because down a group a new shell gets added. Okay, a new shell gets added, like in lithium we have 2 shells, sodium we have 3 shells, potassium we have 4 shells. So a new shells getting added down a group. Okay, resulting in increase in the distance between the nucleus and the valence shell. So distance between the nucleus and the valence shell, it is increases. Okay, as the new shell is getting added in the down the group, and this results in lowering the effective nuclear charge. Okay, this results in lowering the effective nuclear charge and thereby lowering the attractive forces between the nucleus and positively charged nucleus and the electron, and as a result of this the tendency of the atom to lose electron increases and penultimate shell becomes the outermost shell. Penultimate shell means this shell, the inner shell. Okay, inner shell of the valence shell. So the penultimate shell becomes the outermost shell and it has a complete octet state, and therefore the resulting cation has a special stability, and due to this the tendency of an atom to lose electron increases further, and the metallic character of an element is increases while going down the group because of all these factors. Now let's understand the periodic trend while going from left to right within a period. Okay, while going from left to right within a period. So outermost shell remains here in left to right period. Outermost shell remains the same. Okay, like in sodium, magnesium and aluminium, silicon, the only 2 shells. Second period have 2 shells, third period have 3 shells, fourth period have a 4 shell. That means the number of shells remains the same while going left to right within a period. So however, the positive charge goes on increasing. Okay, positive charge of nucleus goes on increasing while atomic radius goes on decreasing. Why decreasing? Because here electrons are increases but shells remains the same. Now resulting effective nuclear charge increasing, and as a result of this the tendency of an atom to lose valence electron decreases. Okay, within a period from left to right, and this is the electronegativity, which is the accept of electron. Okay, that means element accept the or non-metal accept the electrons. And the increasing nuclear charge and decreasing atomic radius, these two factors are responsible for increasing the effective nuclear charge from left to right. And valence electrons are held with a greater attractive forces. Alright, the valence electrons are held with a greater attractive forces, and this property, it is called as a electronegativity. Okay, electronegativity of an atom. And as electronegativity increases from left to right within a period, the tendency of an element to form anion increases. Okay, and hence non-metallic character increases across a period. Okay, now last topic. Okay, non-metallic character. Okay, non-metallic character decreases down a group due to increase in atomic size. Now last topic we have to complete is gradation in halogen family. Halogen family is the elements from the group 17, like fluorine, chlorine, bromine, iodine. Okay, so here elements, the gradation, that means general formula of halogen family is X2. Like here we have of F2, Cl2, Br2 and iodine I2. Okay, so this is a general formula of a group 17 elements. So here a gradation is observed in their physical state down the group. It is observed in the physical state down the group. So here first is fluorine and chlorine. They are present in a gaseous state. They are present in gaseous state, while bromine is present in a liquid state. And last one, iodine, this is present in solid state. Okay. So student, that's all for today. So here we have finished the second lesson of class 10, that is classification of element.